Good day, everyone. Today, I'd like to present our project addressing the inaccuracy and inefficiency in manual inventory management. Our current system is time-consuming and labor-intensive, leading to frequent errors in inventory records. To resolve this, our objective were to create an easy-to-access, secure database for inventory management and to optimize inventory and stock levels. Our solution is a user-friendly IMS database that facilitates easy tracking, promotes data-driven decision-making, and enhances efficiency, accuracy, and profitability in our inventory management operation.
In order to create the inventory management system database, we would like to first understanding the main models required. So through the ERD, which is the entity relationship diagram, we can know the relationship and business rule between each models on how do they connected to each models. So from here we have 6 models, which is the department, employee, box item, and log type, and also the final model is the log item. We can notice that the employee model has the connection with the department model, which is the business rule is employee department ID, where this department ID is listed in the department module. And the main part of the relationship for this project is the log item, which this is the record of the items and its status from the log type. So with that, we can know this item and its status either and its status, either this item has been borrowed, disposed, or added. We can also know who the person in charge report to this log. So this ERD is good to be used before the calculation.
Hello and hi, thank you for the previous presenter. So I will present to you about data query, data creation, table creation, and also for the data dictionary. So the first part is for data dictionary. It's like a guideline for the database. So in this is an example of how data dictionary created, which has the attribute and content, and then the type and length, format, range, default value, unique and required, and need to state you have primary key or foreign key. So this example, like employee ID is for user identification, type is char, and then length is 5, unique, and as a primary key. So you will see this kind of table for the other table also. Same goes to department table also. Data dictionary for box table. So this is for the item table, and this is for the log type table. And lastly is for the log item table, the data dictionary part. So this is a sample of the table creation. So I will show you the rest of the table also. So since you already use the data dictionary, so table creation is like apply the coding, and then you should just refer the data dictionary and type it into the coding. Create table and then table name, and then you just insert the all attribute and then all the character, all the variable, and then don't forget the data type and also the length, and then all the primary key, and then close bracket with the semicolon so that you don't get the error. This is for box table and item table. For the last one, for log type table and then also log item table for the table creation. So we're starting with the query. So we use a box table for this example to include the 3 things, which is insert, delete, and also update. So first is query insert. Remember the syntax is insert into table name and then the attribute, and then follow up with the values that you want to insert. So this is the result when you get from the insert command. Update for the query table, which is update the box name equal to white box, and then where box ID equal to B0105. So update the box and then set the box name into what we want to change, and then where is the place that you want to change. So later on in the result you can see B0105 will equal to white box. Lastly, for the deletion, so delete from box and then where box name equal to red box. So from the result you will not see the red box anymore. So that's all for my part. Thank you. I pass to the next presenter.
Hello everyone. So we will go to the next case studies, which is selection and operation. So from the department table, we want to retrieve the information of all departments. So for the relational algebra, we can see here that there's a pi symbol here, something like pi symbols, and the asterisk represent all. So we will read the SQL statement as select all from department, and the next example is from log item table. We want to retrieve the item ID and item name where the created date is in year 2024. So this is the relational algebra, and the SQL statement we will read select item ID, item name from item where we will extract year from item created date specified on 2024. Yeah, so next for aggregation and grouping operations, this is we are focusing on log item table. We want to retrieve the quantity for log item by log type ID and item ID with quantity in ascending order. So we will select item ID, log ID type, and also quantity. We will focus on from log item table, order by quantity in ascending order. And next from employee table, we want to collect total employee. So this is the row symbol, total number of employee and count employee ID. So the statement will be select count employee name as total number of employee, as you can see here from employees. And for the last example of the case study for nested and subqueries operation, so we want to retrieve the name and department location of employees who work in the same department as a list. Okay. So the SQL statement is select employee name and also the department location from employee E, where we will join department D on E department ID and D dot department ID, where E department ID is equal to select department ID from employee where employee name equal to Alice. And the last nested subqueries example, we want to find the name of employees who have log item exceeds than 5. So this is the SQL statement. Select employee name from employee is E, where exists select one from log item Li. Li represent the log item, where Li employee ID is equal to E employee ID and Li quantity more than 5.
To achieve our goals, we employed two inner joins and three types of outer joins in our database design. First, we use a theta join to identify which department has employee IDs greater than E5000. This helps us segment our data effectively. Then, an equi-join was utilized to determine which department each employee belongs to, streamlining our personal tracking. For outer join, we started with identifying empty boxes through a left outer join. This allows us to pinpoint which boxes are still empty so we can allocate new items efficiently. Next, we use a right outer join to retrieve all items and their associated boxes, ensuring comprehensive visibility into our inventory. Lastly, a full outer join was employed to identify all boxes and items, including those without corresponding matches in the other table. This provided us with a complete picture of our inventory status. This join played a crucial role in ensuring our IMS database operates smoothly and accurately. In conclusion, the IMS database enhances efficiency by automating inventory tracking, reducing manual errors, and providing real-time data. This accuracy prevents stockouts and overstocking, aligning inventory with demand and minimizing waste. SQL queries enable advanced analysis for informed decisions. The system streamlines workflow, boosts productivity, and reduces labor costs. However, careful integration, robust cybersecurity, and thorough training are essential to mitigate drawbacks. Implementing suggestion improvement will enhance the system resilience, reliability, and security. Thank you.